Today we're going to learn how to write linear equations when we are given 2 points. So when we've been writing linear equations, we've always done y equals mx plus b, where m is our slope, b is our y-intercept. We fill in those two things every single time. We've done it before where we were given both of those pieces and we just had to plug them in. We've done it from a graph where we had to find those two pieces, and we've done it from a point and a slope where we were given the m but we had to find b. When we have 2 points, we are actually given neither of those information, so we have to find both m and b. So that's an extra step from what we learned last time. So we have our 2 points. Remember, it's always x and then y. And our slope formula, we found slope before, so this isn't new. Y minus y, x minus x. And then we can either use point slope form, which is y minus y1 equals m times x minus x1, or we can use the y equals mx plus b, plugging in to solve for b. Here we would be plugging in these 3 places. That's what we learned last time when we had slope and a point. So after we find slope, then we just do it the same way as we do with slope at a point. So we have 2 points. We have our x and y values. The very first thing we need to do is find slope. So I'm going to do y minus y. I have -4 minus -2. I took my y values and I subtract them. And on the bottom, we're going to do x minus x, -2 minus 2. When I have minus and negative, that turns into a plus. So on the top, I get -2, and on the bottom, I get -4. We want to always try to simplify our fractions when we can. 2 negatives makes a positive, and 2 over 4 simplifies to 1/2. So I'm going to write over here m equals 1/2. We just found our slope. Now that we have slope, we can do the same process as we did with slope and a point. I have 2 points to choose from. It does not matter which point you choose, you'll get the same answer. I would try to use a point with smaller numbers or with less negatives. In this case, I would choose this point because it only has 1 negative instead of 2 negatives. Again, it totally doesn't matter. We're going to use this point and this slope and plug it in to either point slope form or slope intercept form, depending on which method you like. So I'm going to go ahead and do point slope form first. Y minus our y value of the point that we chose, -2, equals m, which we found to be 1/2, x minus our x value in this point is 2. Make sure that when we choose a point, though, we have to use the x and y value from that point. I can't choose the y value here and the x value here, or vice versa. It has to be the same point the whole time. So I can either set it up this way, or we can do y equals m x plus b. And I just plugged in my m, my x, my y values. So this is what we learned last time, how we simplify these equations. This would be y plus 2 when I have minus a negative. I distribute my 1/2 to get 1/2 x minus 1. Over here I multiply 1/2 times 2 to get 1, and the -2 stays the same. Subtract 1 from both sides, and -3 equals b. Here I'm going to subtract 2 to get y equals, and I get y equals 1/2 x minus 3, which is the same thing I would get here with one more step. Our m is 1/2, and our b is -3. Same answer, 2 different methods to use it. I'm going to also go ahead and show you, if I had chose this point, I still would have gotten the same answer. I am going to just use point slope form on this one. Y minus -4 equals 1/2 x minus -2. I just plugged in my y value here, m and x. This turns into y plus 4. This is plus, so I distribute to get 1/2 x plus 1. And then I subtract 4 to get y equals 1/2 x minus 3. So there's a lot of different options we have here. I get the same answer. I did it 3 different ways. You can pick one of your 2 points. This one I picked this point, got the same answer as I did when I picked the other point. Doesn't matter. You can choose to use point slope form, or you can choose to plug it into slope intercept form and solve for b. It doesn't matter. So you get to choose some things here. Just make sure that when you're choosing them, you are consistent and that you find the correct slope first. Okay, got a couple more examples. Always want to label the x and y values to make sure that we don't mix that up, because slope is really important. Y minus y over x minus x. A lot of people get those mixed up. We always want the difference of y on the top. So -1 minus -4 and 3 minus 4 turns into a plus, and I get 3 over -1, and that simplifies to -3. So my m is -3. Now I'm going to use this, and I'm going to pick a point. I'm going to go ahead and choose this point because it's got smaller numbers. But again, it doesn't matter. You pick whichever point you want. Y minus -1 equals m times x minus x, or y equals m times x plus b. This turns into a plus. Y plus 1 equals -3x plus 9. When we distribute negative times a negative, we get a positive 9. Subtract 1, y equals -3x plus 8. Over here, we multiply to get -9. And then we add 9 on both sides to get 8 equals b. Plug 8 into our b value and -3 into our m. We get -3x plus 8. Okay, last one. We have our x and y values. Y minus y goes on top. X minus x goes on the bottom. So we get 0 over -3. When we get 0 on the top, 0 divided by anything equals 0. So our m equals 0. I can still plug in 0, so that's okay. We're going to pick a point. I would go ahead and choose this top one. It's got smaller numbers with the 1. Y minus 5 equals m, which is 0, x minus x, or y equals m x plus b. I can still plug in 0 and it's going to work out just fine. When I distribute 0, 0 times anything would be 0x plus 0, so I can just write that as 0. 0x plus 0 is just 0. And I have y minus 5, so the opposite would be plus 5, and I get y equals 5. Notice this looks a little bit different than y equals mx plus b, but we've talked about this before. Whenever the slope is 0, we're not going to see the x. We're going to have this horizontal line when we graph it, y equals 5, 0 slope, we don't see the x, there's no slope. Okay, over here, 0 times 1 is 0. And I could subtract 0, it's not going to do anything. 5 equals b. So y equals m, I could write 0x plus 5, but remember that 0x doesn't do anything, so basically we just have y equals 5. Anytime we have a slope of 0, we can just look at our y value. So instead of doing all of this work, when I get 0, I can look over here and I say, oh, y equals 5 in both of those. So I could just say y equals 5. That's a little shortcut. If you notice that the slope is 0, just write what the y value equals. to save yourself some time. Along the same lines, sometimes we have our x values are the same. And let's see what happens there. Y minus y over x minus x. We get 10 over 0. And we've seen this before when I have 0 on the bottom of a fraction. This is an undefined slope. We cannot divide by 0. Okay? Undefined slope. I can't plug in the word undefined into an equation. That doesn't make any sense. But if we remember from graphing, undefined slope gives us that vertical line, and it's always x equals something. So I know when I get a 0 on the bottom, undefined slope, we're going to have x equals. And then I just look, what does x equal? It is 2 in both of those equations. So x equals 2. So those are kind of quick and easy. If we know that the slope is undefined or the slope is 0, we can just jump and see, okay, there's a common y value here, y equals that number. There's a common x value here, x equals that number.